Okay, last video for 2.4. We're doing vertical motion. So instead of things traveling horizontally, we're now talking about things falling vertically. So here's our equation for a ball thrown into the air from the top of a cliff. So we're at a cliff here. Here's my little stick figure me. I'm going to throw a ball into the air, and then it's going to fall down. So my vertical motion is going to look something like that. So 16 says find the initial velocity. That would be v of 0. Before we can do that, we at first need to find the equation for velocity. So velocity is the derivative of position. So I'm going to take the derivative of this. I'm going to start going a little bit faster. So I move the 2 in front times the negative 16 would give me negative 32t. And then I do 2 minus 1, which would be t to the 1. Plus 48, the secret 1 moves in front. And then I would have 1 minus 1, so that t goes away. And then the derivative of the constant is just 0. So that should be my velocity equation. And this one asks for initial velocity, so that would be v of 0, which is going to be 48. Now this is a velocity problem, so it's going to be feet per second. We have feet and seconds. Okay, number 17, at what time does the ball hit the ground? If it's going to hit the ground right there, sorry about that, guys. Okay, we're back. So we want to know what time does the ball hit the ground. So we want to know what is t at that time. So if we think about this, when the ball hits the ground, that's when the position s of t equals 0. 0 feet. Up here it would be some feet in the air. Here it would be like 2 feet off the ground. When it hits the ground, that's when the position is at 0 feet. So what I'm going to do is take my position equation and I'm going to set it equal to 0. And now I need to solve this. So a couple different ways you can do it. This one actually factors out really nicely, no decimals, so you can do it pretty quickly by hand by seeing we have a GCF of 16. So if I take that greatest common factor out, I'm left with that. And then I can factor that inside to t minus 5, t plus 2. And now I set my two parentheses with variables equal to 0. If we had a t out here, we would also set negative 16t equal to 0. But there's no letters out here, so we don't need to worry about it. So now I solve, and I have t equals 5 seconds. And then I have t equals negative 2 seconds. Now, one thing really quick, we said we can't have negative time. So it's going to be 5 seconds. So 5 seconds after I throw it, the ball hits the ground. Okay, last one. At what time does the ball reach its maximum height? So if I look at this picture here, the maximum height is right there. What do you notice about the slope at that maximum height? Well, the maximum height is where the slope is 0. So a really easy way to find a maximum is to set the slope or velocity equal to 0. So I'm going to take my velocity equation, set it equal to 0, solve it, so then I have t equals 48/30 seconds, or if you simplify it, 1.5 seconds. So 1.5 seconds after I throw it, it reaches a max, and then it starts to fall. So that's all your notes for today. Go ahead and get started on your assignment.